Today we have to know that is centripetal force. First we have given the definition of centripetal force and then derived the equation of the force. This is very important part. So first we have to know what is the centripetal force. So it is the force acting along the radius towards the center and is essential to keep the body going round in a uniform circular motion. In a uniform circular motion. Example, that is earth moves around the sun in circular orbit the centripetal force appears due to the gravitational attraction between the sun and the earth. This is a non-contact force. This is a non-contact force. The equation of centripetal force, that is Fc equal to mv square by r or m omega square r. So next we have to know this force does not work. So it is a centripetal force is a workless force. Let W is work done. W is work done by the force F, which creates a displacement that is S. Then we can write W equal to F dot S. Since the centripetal force is perpendicular to the direction of motion, so we can write that is F dot S equal to 0. F dot equals 0, so W equal to 0. Hence we can write the centripetal force. Hence centripetal force does no work. So now we have to derive the important equation. Let a particle of mass m moving along a circular path of radius r. Let a particle mass m is moving on a circular path of radius r. The angular velocity is omega. Let the particle is moving from point A to point B, making an angle that is theta. Point A to B and making an angle theta. So in time that is t, making angle theta in time t. Theta is very small, hence we can write that is cos theta equal to 1, sin theta equal to theta. So at point A, the velocity is v, that is along AC, acting along AC, in there is no component along in this direction. There is no velocity component along AO. There is no velocity component. So at point B, the velocity has two components. Number one, that is v cos theta. Number two, that is v sin theta. Since theta is very small, so we can write this is v acting, that is BE, So v sin theta, this is theta acting that is BF, that is acting along BF, VF. This is along BF. So v cos theta, that is v, so acting along BE in this direction, and this is v sin theta, that is theta, so acting along BF. So along AO, the initial velocity along AO, that is 0, and along AO, that is in this direction, the final velocity, that is we can write, along BF means that is theta, so we can write that is here, that is v theta, so we can write that is v theta. So we have to know two component, that is v cos theta, that is v, since theta is very small, so cos theta equal to 1, so that is v along BE, and next that is v sin theta equal to v theta, so this along BF, along this direction v theta, so final velocity, that is v theta. So change in velocity along AO is, that is V theta minus theta, so we can write V theta. So rate of change of velocity, that is V theta by t, because the particle is moving from A to point B in time t. So V theta by t. So this is Fc. So V theta by t. So Fc equal to, that is V omega. We know that is theta by t, we can write that is omega. So we know V equal to omega r, so we can write Fc equal to, that is omega square r. Again Fc equal to, we know that is omega square r. We can write that is V square by r. This is equation 1 and this is equation 2. So these are centripetal acceleration. These are centripetal acceleration. So we have to one thing remember, that is along AC there is no rate of change of velocity, because along AC, that is V, that is initial velocity, and along BE, that is V. So V minus V, that is 0. So there is no change in velocity along AC or along BE. So hence only velocity change occurs along AO. So we get the acceleration along AO. So that is omega square r and V square by r. Now centripetal force that is Fc equal to, that is m omega square r and Fc equal to m V square by r. This is equation, that is 3. This is equation, that is 4. So this is the main equation of centripetal acceleration. So the equations 3 and 4 are the equations of centripetal force. So we can give the definition, that is the centripetal force. So centripetal force is the force that acts along the radius towards the origin and is essential to keep the body in a circular orbit. So this is known as the centripetal force. So we give another example of centripetal force, that is an electron moves around the nucleus Around the nucleus of an atom, the required centripetal force is supplied to the electron due to electrostatic attraction between electron and nucleus. So this is non-contact force. This is non-contact force. With the help of the centripetal force, we have to calculate some numericals. First numericals, that is, here the n is given, that is n 150 revolution per minute. So we can write 150 by 60, that is revolution per second. We can write omega, we can write that is 2 pi n, so 2 pi into 150 by 60, so we can write this is, that is 5 pi, that is 5 pi rad per second. So r is given, r that is 0.6 meter, and m is given 0.2 kg. So we can write that is Fc equal to m omega square r, m that is 0.2, omega that is 5 pi tar whole square, that is 0.6. So we can write this is the value, that is 29.6. So tension in the string, is, that is 29.6 Newton. Next problem, this is the problem. We can write here, we can write, so r that is 0.46 plus 0.46 plus so 0.015 meter. So this is the diameter by 2, that is the value 0.015, and this long, that is 0.46. this is a sum is given, that is r. So r is, we can write that is 0.475 meter. So n is given, n that is 50 revolution per second. So we can write omega equal to 2 pi n, that is 50. So we can write that is 35 rad per second. So m is given, m that is 0.03 kg. So we can write that is Fc equal to m omega square r, m that is 0.03, omega that is 30 pi tar whole square, r that is 0.475. So we get the value that is fc equal to, we can write that is 1.266 into 10 to the power 3. So tension is that is 1.266 into 10 to the power 3, that is Newton. So today I have calculated the equation of centripetal force, and we explain what is centripetal force. We explain with example with centripetal force, and we solve two problems. Today we derive the equation of centripetal force and also define what is centripetal force, and with the help of centripetal force I have solved two numericals. These are very helpful for class 11 students. I think this class is helpful for students. Please watch all the videos and make comments and like and share all your friends. Thank you all your students. Thank you.